Okay, in today's lesson, we're going to talk about many different ways on how to factor polynomials. And you should be familiar with many, if not all, of these different methods for factoring. So, let's first talk about how to find the greatest common factor and what that means. So if you are being asked to factor over the integers, you're trying to find an equivalent expression that is a product with the integer coefficients. So if we can't do that, if we can't find different products with integer coefficients, then we would say that it's not factorable or it's prime. So either one of those terms is fine. Prime is more user-friendly and the word that's most often used to describe factors that can't be factored completely. What does it mean to be factored completely? That means each of the polynomial factors itself is prime or irreducible. That think of your factor tree. You've factored it completely when all of the base factors can't be factored any further. No common factors. Now, the greatest common factor is an expression of the highest degree that divides into each of the terms of the polynomial. So you want to look at the polynomial, look at all the terms and say, what is the greatest common factor that exists? So if I look at this first cubic binomial, I'm looking at each of these two terms and I'm saying, what is the most I can divide out of each term? I see 18 and 27, so 9 goes into each of those. So I'm going to factor out a 9 from the coefficients, and then x squared is the greatest power of x that I can divide out of each of those terms. Now, what remains once I take out the greatest common factor is the result of actually performing the division. So I'm going to take this first term and I'm going to divide it by 9x squared. So 18 divided by 9 is 2. X cubed divided by x squared is x. And then I have 27 divided by 9 is 3. X squared divided by x is 1. So my final answer in factored form is the greatest common factor on the outside and the result of actually performing the division inside the parentheses or the brackets. Now, if I look at the next example, I'm looking at this and I'm looking at this. And I'm asking myself, what is the most I can divide out of each of those? Well, hopefully you notice that each of them has an x plus 3. So my greatest common factor is actually the x plus 3. Now the result is what's left over once I perform the division. So if I take the first term and I divide it by x plus 3, I'm going to get x squared, plus take the second term and divide it by the greatest common factor, x plus 3, and I'm left with 5. Now, if I could factor further, I would, but I can't, so this is factored completely. Now, that's great if a greatest common factor exists, and you want to go ahead and always look for a greatest common factor because whatever you're working with is easier once you factor out the greatest common factor. Now, the next method is factor by grouping. So let's say you're given, in this first example, we have a cubic 4-term polynomial. Now, you may look at this and say, well, is there a greatest common factor? There is not a greatest common factor among each of those terms. So instead, you may want to group some of the terms together and factor independently. There may be more than one way to factor by grouping and get an equivalent answer. So let's go ahead and take the first two terms and let's find the greatest common factor in the first two terms. The greatest common factor in the first two terms is x squared. The result once I divide each of those terms by x squared, is x minus 1. Then I'm going to look at the next two terms, and I'm going to ask myself, what can I factor out of each of those? Well, I'm going to factor out a minus 5, and if I do that, I'm going to be left with x minus 1. And you want to try to choose values cleverly so that you could maybe continue to factor. And now at this point, I do see that each of these terms has an x minus 1. So I'm going to go ahead and factor out an x minus 1 from each of those. And what's left? X squared minus 5. Now, if I could factor any further, I would, but I can't, so I won't. If this had been a 4 instead of a 5, that would have been the difference of two squares, and I could continue to factor. But at this point, that's all I could do. Now, go ahead and take a moment and try to do the next few examples and see if you get the same answer as I do. Pause it, work them out. I'm going to factor by grouping. In this case, I'm factoring out an x squared, leaving an x plus 5. In this case, I'm factoring out a negative 2, again leaving an x plus 5. I see they each have an x plus 5, so I factor that out, leaving me x squared minus 2, and it's factored completely. Hope you got it. Next one, cubic 4-term polynomial. Again, I'm going to go ahead and factor by grouping, choosing the first two terms and the last two terms. Greatest common factor of the first two terms, x squared, leaving me x plus 4. Greatest common factor of the last two terms is 3, leaving me again x plus 4. I see they each have an x plus 4, so I'm going to factor out an x plus 4 from each of those, leaving me x squared plus 3. And I can factor no further. Now, what happens if you have a trinomial? So in this case, I have a trinomial, and let's go ahead and say with this quadratic trinomial, I want to split the middle. Now, I'm going to first assume that I'm dealing with the leading coefficient equaling 1. So if the leading coefficient equals 1, so if a equals 1, then I have x squared plus bx plus c. So let's go ahead and take a look at those. The first thing you want to do for any quadratic trinomial is you do want to multiply a by c. In our case, we're looking at a being 1, but the first thing you want to do is multiply a by c. Once you get that product, you're going to try to find two factors of that product that sum to b, meaning two factors add to give me b. Then what you're going to do is you're going to split the middle term with these numbers as coefficients. So let's walk through this process. Here you have a quadratic trinomial. Let's first identify a, leading coefficient, 1. Let's identify b. b is 6. And let's identify c, which is 8. So I've found my a, b, and c. The next thing I want to do is I want to go ahead and multiply a times c. So if I multiply a times c, I'm going to get 8. And I'm trying to find two factors, two numbers that multiply to give me 8, but add to give me 6. So those two numbers would be 2 and 4. 2 times 4 is 8, but 2 plus 4 gives me that 6. So I'm going to split the middle term, bring down the first term, bring down the last term, and I'm going to split the middle term into 2x plus 4x. So this 6x has been split into the sum of 2x and 4x. Then I can factor by grouping. As we just did. And I'm going to get x plus 2 times x plus 4. And I can FOIL that to check to see if I actually get my original quadratic trinomial. And I do. But that's splitting the middle. So go ahead and try these examples. I will work them out, but go ahead and try them and see if you can get them on your own. If you can't factor them, especially by splitting the middle in these examples, they may be prime, so keep that in the back of your head. But let's go through this process that we just outlined and try to do these problems. So go ahead and stop the video if you would like and try to do them. Factor by splitting the middle, I'm going to identify A. I'm going to identify B. And I'm going to identify C. And then I'm going to find AC, which is 40. And then I'm going to find two factors of 40 that add to give me 13. And that would be 8 and 5. So bring down the first term, split the middle term into 5x plus 8x, bring down the last term. Factor by grouping. Find the greatest common factor and what's left. And this is factored completely. Again, you can FOIL this to see if you end up with the original quadratic trinomial. Again, A is 1, B is 13, C is negative 18, oops, not 13, my mistake. B is 3, not 13. And C is negative 18. So then AC is negative 18. Looking for two factors that multiply to give me negative 18, but add to give me 3. So that's 6 and negative 3. Bring down the first term, split the middle term, bring down the last term. Factor by grouping. Factor out the greatest common factor from each. And FOIL to check. Next one. A is 1. B is negative 5. C is negative 14. So AC is negative 14, looking for two factors, two numbers that multiply to give me negative 14, but add to give me B, negative 5, negative 7, and 2. Bring down the first term, split the middle term, bring down the last term, factor by grouping. Greatest common factor, and FOIL to check. Next one. A is 1. B is negative 4. C is negative 5. AC is negative 5. Looking for two numbers that multiply to give you negative 5, but add to give you negative 4. Negative 5 and 1. Bring down the first term. Split the middle term. Bring down the last term. Factor by grouping. Factor out the greatest common factor. And FOIL to check. Now, let's go ahead and look at quadratic trinomials. We're still going to split the middle, but now we're going to look at what happens if the leading coefficient, if that a is not equal to 1. So it's the same process. So if you want to go ahead and try these, you can. And pause the video and check as you go. Remember, if it's not factorable, it is prime. Unfactorable polynomials are prime. So I'm going to go ahead and work them out. A in this case is 8. B is -10. C is -3. AC is -24. Looking for two numbers that multiply to give you -24, but add to give you -10. -12 and 2. Bring first term down. Split the middle term. Bring the last term down. Factor by grouping. Greatest common factor of the first two terms is 4x, leaving you 2x minus 3. Well, greatest common factor of the last two terms is just 1. This allows us to have greatest common factor 2x minus 3. And you are left with 4x plus 1. You need that 1 here. If you don't put a 1 there, then you don't have a binomial here, and it's a disaster. FOIL to check to make sure that you got the correct factors. A is 3. B is -1. C is -2. Now, we could be mean and not give you these polynomials in standard form to try to trip you up, so do make sure that they're in standard form first. AC is -6. Then your A, B, and C are all wrong, right? Because you didn't put it in standard form first. We're not going to be that mean right now. Hint. So bring the first term down. Split the middle term. Factor by grouping. Greatest common factor is x minus 1. And you are left with 3x plus 2. Again, FOIL to check them. Next one. A is 320. B is -32. C is -15. AC is -4800. Now, this is a large number, so you may be toying with this for a while trying to figure out the factors. You could use a 4-function calculator to just start performing division. I don't know how hard you tried. I hope you didn't suffer too much, because this one, my dears, is prime. It's not factorable. Okay, next one. Ooh, 2 variables. So we have to be careful how we're doing this. We have to make sure when we split the middle that we are actually bringing down the correct variable-based factors. So A is 6. B is -7. C is -5. AC is -30. Two numbers that multiply to give us -30, but add to give us -7, -10, and 3. So be very careful here. We're going to bring the first term down. We will bring the last term down, but be very careful how you split this middle term. It is an XY term. So while we're still using these numbers as the coefficients, it is XY. So be careful. Now, also pay attention when we are finding the greatest common factor when we factor by grouping. In the first instance, I have 2x and then 3x minus 5y. And then I have y, 3x minus 5y. That allows me to have 3x minus 5y as one of the factors and 2x plus y as the other binomial factor. So that one is factorable. More practice. So go ahead and try more practice if you need more practice with splitting the middle. You can pause it, try it, and check it if you want the practice. I'm going to work them out for you. A is 15. B is negative 19. C is 6. AC is 6. Finding factors that multiply to give you 6, but add to give you negative 19. What do we have? Negative 9. Oops. AC is 90. Where did I get that? 90. So multiply to give you 90, add to give you negative 19. Negative 9, negative 10. So I have 15x squared. Split the middle. Negative 9x minus 10x plus 6. Factor by grouping. So greatest common factor. Greatest common factor. And I'm done. Next one. A is 6. B is 19. C is negative 7. So AC is negative 42. Finding two numbers that multiply to give you negative 42, but add to give you 19, 21, and negative 2. First term. Split the middle term. The last term. Factor by grouping. Greatest common factor. What's left? Foil to check. Next one. A is 2. B is negative 7. C is 3. AC is 6. Two factors that multiply to give you 6, but add to give you negative 7. First term. Split the middle term. Be careful, it's an XY term. Factor by grouping. Greatest common factor. And what's left? Next one. A is 3. B is negative 13. C is 4. AC is 12. Looking for numbers that multiply to give you 12, but add to give you negative 13. Negative 12, negative 1. Bring your first term down. Split the middle term. Be careful, it's an XY term. And bring the last term down. Then we have greatest common factor by factoring by grouping. greatest common factor, and what's left. So hopefully you've had enough practice with splitting the middle. Now, special products. This is actually the next section, subsection within factoring, so P.5b. We've already talked about the difference of two squares. We have the difference of two squares, a squared minus b squared. We know that to be the product of conjugate pairs. Oops. We know we could FOIL, and the middle two terms would cancel out. That's where we get the a squared minus b squared. So if we can identify a and b, factoring these difference of two squares is easy. So practice, FOIL to check. The first term in each has to be the square root of this term, so 9x. The last term has to be the square root of the last term, and they are conjugate pairs. And then this one, you see an x to the fourth, but don't let that freak you out. This is still the difference of two squares. The first term in each binomial of the conjugate pairs has to be the square root of that. The second term has to be the square root of that. And these are conjugate pairs. Oh, but I'm not done. I see another difference of two squares. So while I can bring down this first one, I can't factor this over the real numbers. A little foreshadowing. However, I can factor this, again, as the difference of two squares. So this is x plus 3, x minus 3. And now it is factored completely. So do make sure you go as far as you can go. Perfect square trinomials, that was the result of our squaring the sum and difference of binomials. And this should ring a bell. This is the coefficients of Pascal's triangle. With this sum, we should recall that this is what it is. You should commit this to memory. And then for the difference, the first term is positive, then negative, then positive. So if I look at this one, they're all sums. This is the sum. Perfect square trinomial, so it's a sum, and I could actually FOIL that. And then this one, I'm looking at this, and this is a perfect square trinomial, plus minus plus, so this is actually 5x minus 6. Now, some people see these, some people don't. Sometimes it takes a little bit of toying. Can you split the middle? Yes, if you don't recognize that these are perfect square trinomials. Now, what about the sum and the difference of two cubes? So if I have the sum of two cubes and the difference of two cubes, these take some toying with, but you should really commit these to memory. These need to be ready, available factors. So for addition, for the sum, it's a plus b times a squared minus ab plus b squared. And you should recognize where this is coming from a little bit. And then this one is a minus b, a squared plus ab plus b squared. Okay, so this is plus. So this is plus and the others alternate. This is minus, so this is minus, but they're all positive. So again, those are things that you really want to, you should know these. I mean, I'll tell you now, these are going to appear and you're going to hate yourself if you don't know how to factor the sum of the difference of two cubes. So in this case, if we identify A and we identify B, okay, so in this first one, I see that A is 1. b is 8. So if I'm looking at cubes, perfect cubes, the cube root of 1 is 1. The cube root of 8 is what? 2. So I have x plus 2. And this is the sum, so I'm using the first formula. And then I have a squared minus ab plus b squared. And this is as far as I can go. This one, these are both perfect cubes, so a is the cube root of the first term. And I should put x's here technically. No, I'll put x for this one. And then b is the cube root of 125. So a is 4x. 4x times 4x times 4x gives me that 64x cubed. B, the cube root of 125, is 5. 5 times 5 times 5 is 125. So using the difference of two cubes, a minus b, a squared plus ab plus b squared. Few more practice problems. Go ahead and work these out and see if you can recognize what special factor patterns exist. Feel free to pause it and then come back and check. First one, you should recognize this as the difference of two squares. So a is the square root of 81 x to the 4th. B is the square root of 16. So a is 9x squared. B is 4. So if I factor this, I'm going to get 9x squared plus 4 times 9x squared minus 4. While the first binomial is prime, this one can be factored further as 3x plus 2, 3x minus 2. It's again the difference of two squares. So it's difference of two squares twice. The next one is perfect square trinomial. So it's actually 4x minus 7 squared. The next one is the difference of two cubes. So a is the cube root of 125x cubed. B is the cube root of 8. So I have 5x and 2. So that gives me 5x minus 2. I'm just filling into the formula. For the difference of two cubes. And I'm done. Now, this is mixed factoring, so let's go ahead and take a look at how we would factor these. This is more practice. We're going to use all our skills, and we have to be clever. So in the first one, again, you want to always check to see if you can get a greatest common factor out. If you can get a greatest common factor out, you're making the problem easier. So if I look at each of these terms, hopefully you can recognize that the greatest common factor is 2x. So greatest common factor is 2x. So let's go ahead and divide each of those three terms in this cubic trinomial by the greatest common factor. So that's going to leave me x squared plus 4x plus 4. So now all I have to do is factor this. And hopefully you see it as x plus 2, x minus 2. x plus 2, x plus 2, sorry. If you do want to condense that and represent it like this, it is fine. But either of these are fine answers. I don't care. Factored, normally you want to put it in this first form when you're trying to write things in factored form. But I'll accept the second one. Okay, the next one, we have to be a little clever here. A little clever. I see 4 terms. I don't see a greatest common factor, so maybe factor by grouping. So I'm going to look at the first 2 terms and the last 2 terms. First 2 terms, greatest common factor, 3y, leaving me 4x squared minus 9. And then the last 2 terms, factor out a -1 so that I can get another 4x squared minus 9. So I see greatest common factor. And what is left? But do I stop there? Oh, heavens, no, I don't stop there. Why? Because I see a difference of 2 squares. So I do need to go further. But of course, bringing down that last binomial. Now it is in factored form. Next one. What do I do? Oh, gosh. Now, your gut instinct may be telling you to factor by grouping. We could try to do that. But, you know, there's other clever ways we can look at this as well. What if I were to rewrite this as x squared plus 8x plus 16 and then minus 25a squared? What if I did that? And the reason I did that is because now I can look at this and recognize that as x plus 4 squared, quantity squared. Because now I have the difference of 2 squares. So my first term is x plus 4 plus 5a, and then x plus 4 minus 5a. And that's a good looking answer. I can't combine those any further. Next one, what do we want to do? Greatest common factor. Greatest common factor. Let's make this easier to factor. Let's factor out a 2x. Okay, see what we have left over inside. So I took out the greatest common factor. So that's going to just perpetuate. In every step, that is going to perpetuate down. I'm only going to work with what's inside the parentheses. Again, I'm going to go ahead and rewrite the inside in a different order. So x squared plus 14x plus 49. I took these 3 terms. And then I have left minus 49a squared. And the reason I did that is because I can look at this and see that as x plus 7 quantity squared minus 49a squared. Difference of 2 squares. So again, I have inside of here x plus 7. That's an exponent if you can't tell. It doesn't really look like one, but it is. Quantity squared minus 49a squared. I can go further. Kind of just rewrote that again by accident. Thinking x plus 7 plus 7a, x plus 7 minus 7a. Now those are kind of tricky. Those last couple ones are kind of tricky. Those were just fun problems. Now, what happens if I have rational exponents or negative exponents or negative rational exponents, fractional exponents? These can get a little out of control, and they're beautiful problems. And, you know, you should toy with ones that are a little bit more complicated. And let's talk about how we would go through these. Now, remember, if you're given a polynomial, in this case, a quintic binomial, you want to look for a greatest common factor first. Let's make the problem easier if we can. So, greatest common factor, and then notice the difference of two squares. Now, same process holds true even if I have rational exponents. Greatest common factor. Greatest common factor, if your exponent is a rational exponent, a fractional exponent, it's actually going to be the smallest exponent. So fractions are, you know, they can trip you up a little bit. So if I look at each of these, I'm going to ask myself, what is the greatest common factor? Well, the most I can divide out of each of these is actually going to be x to the 1/4 power. So what's left over, so that's my greatest common factor. If I divide each of these terms by x to the 1/4, well, 3/4 divided by 1/4, remember you have to invert and multiply, that's going to give me x to the 2/4. And then anything divided by itself in this case is going to be x to the 0 power, so that's going to be 1 if I use my rule of exponents. Let's simplify, and I'm good. So that's my answer. Okay, let's try another one. In this case, I can factor out a 6 from each of them, but what is the exponent for x? Negative 3/4 is smaller than 1/4, so that's the most I can take out of each of them. The first term divided by the greatest common factor is going to give me 2. The second term divided by the greatest common factor is going to be x. Why is that? 1/4 divided by negative 3/4. X to the 1/4 rather divided by x to the negative 3/4 gives me x to the 4/4, which is x to the first, which is just x. Now, I want to rewrite this without a negative exponent. So I see that this term here has a negative exponent. This base factor has a negative exponent, so it has to move to the denominator. So in the numerator, I have x times 2 plus x, and in the denominator, I have x to the 3/4. That is my final answer. Now, they get a little bit more fun. I'm looking at each of these, and I see that they each have an x squared plus 4. But what is the exponent? The smaller of those two is 3/2. So that's going to leave me with 1 minus x squared plus 4 to the 2nd power. I need to FOIL. Oh, I can see that this is the difference of two squares. Why? Let's go ahead and just leave this alone. Notice that the inside is the difference of two squares. So I have 1 plus x squared plus 4. And I have 1 minus x squared plus 4. So I have to distribute here. So let's go ahead and distribute. I have x squared plus 4 to the 3/2 power. And then I can combine this 1 and this 4 to get x squared plus 5. And then this is going to be 1 minus x squared minus 4. So if I combine these, what do I have? Still have this x squared plus 4 to the 3/2 power out front. There's nothing I can do with this. However, I have a negative x squared minus 3 here. And I kind of don't like this minus sign here. So I can factor that out. I can factor out a negative from these and bring it out in front. Now that's going to freak y'all out a bit. But the joys of math. That's going to leave me x squared plus 3. That's beautiful. Now, last problem on this page. Let's go ahead and look at each of these and see what I can factor out of each of those. It's going to be an x plus 1, and the smallest exponent is negative 3/4. So that is going to leave me with x plus 1. And then I can bring this down. And I can go ahead and clean that up by combining like terms. And then I don't like that negative exponent, so I have to get rid of the negative exponent by bringing that base factor to the denominator. And that is my final answer. Here's more practice. If you would like more practice, go ahead and try these. If you really want to be challenged, these are some more practice problems. Feel free to pause the video and work on these and come back and check your answers. Okay, so I have x, greatest common factor, smaller of the two rational exponents, giving me x to the 4th, x to the 0, x to the 1/4, x to the 1/2 minus 1. Okay, that looks very familiar. Next one, looking at each of these two terms, x squared plus 4, 3/2, giving me x squared plus 4 to the 0 plus x squared plus 4 squared, x squared plus 4 to the 3/2. This is 1 plus, I'm going to go ahead and FOIL this. It's x to the 4th plus 8x squared plus 16. And the reason I went ahead and went one step further is because now I can combine those. So that's 17. It's ugly. 17. Okay, now I'm looking at this, I'm looking at this. What do they have in common? Well, 2, and then 4x plus 3 to the negative 2 power. What's left over? Negative 4 plus 5 times 5x plus 1, then do the division. And then I'm going to go ahead and multiply this and combine like terms. And that is going to give me but I don't like this negative exponent term, so I'm going to rewrite this as 2 times 100 x squared plus 95x plus 11 over 4x plus 3 quantity squared. Okay, next one, looking at these, I can take out by division, greatest common factor, 6x to the negative 3/4, leaving me 2x to the 0 plus x to the 4 over 4, which is 1. Okay, so that's 6x to the negative 3/4, 1 minus x, no, 2, sorry, 2 minus x. I'm going to move this term with the negative exponent to the denominator, so that gives me 6 times 2 minus x over x to the 3/4. Final answer. Okay, next one, looking at these, greatest common factor, x squared plus 3. The smallest exponent is negative 5/3. Okay, perform the division. I have x squared plus 3 to the 3/3 power, and then x squared plus 3 to the 0 power. Let's simplify what's inside the bracket. So that's x squared plus 3 plus, and then this gives me 1. And then I can combine these. So I have this. And then inside I have x squared plus 4. But I don't want this negative exponent, so I have to move it to the denominator. So that equals x squared plus 4 over x squared plus 3 to the 5/3 power. These are out of control. These are great problems. Next one, I have 4x minus 1. Smallest exponent is 1/2, leaving me with 1 minus 1/3 times 4x minus 1. I am going to distribute. So I have 4x minus 1 to the 1/2. 1 minus 4/3 x plus 1/3. Then I'm going to combine these. 1 plus 1/3. So that's 3/3 plus 1/3. So that's 4x minus 1 to the 1/2. And that is going to give me negative 4/3 x plus 4/3. And I'm going to factor out that 4/3 in front. And that is going to give me 1 minus x inside. And that is my final answer. So hopefully that's a lot of practice there. Here's just a thought process on how you want to go about your strategy for factoring polynomials. So of course, always look for a greatest common factor first, and then see if it's one of the special products. Is it a difference of 2 squares? Is it the sum or difference of 2 cubes? Is it a trinomial? If it is, then see if you can split the middle, or if it's a perfect square trinomial. Sometimes you just have to guess and check, and FOIL to check to see if you get the original expression. If there's 4 or more terms, perhaps grouping, and there's different ways we can group. Once you've completed this thought process, maybe you get that it's prime.